Hi everyone. So I just wanted to go through the requirement for the math component for the Making Life in Quarantine Better project. All right, so the first thing you want to do is you want to go to our Google Classroom, and I'm just going to show you how to find the rubric in case you're not sure how to do that. So classwork, and then project number 2, and then just scroll down until you see the post that has the rubric, and it's right here, April 7th. Okay, and this is the rubric for all the different subjects that are required, and math is right here. So I just copied that into my slide. All right, so first thing you want to do is you want to design and carry out an investigation or an experiment involving relationships between two variables, and then explain your experiment including a hypothesis. All right, so you're going to start out with a question, and then from that question you're going to create your hypothesis. Your hypothesis is going to be a statement. All right, it's not a question. The hypothesis is an educated, testable prediction about what will happen. All right, so your hypothesis should be in this form here. It should be something like, if I do this, then this will happen. So I went through and I made up an example that I'm going to use for to explain what the requirements are for the project. So the question I thought of was, I'm wondering if my mark depends on the number of hours I study. My hypothesis from that would be, if I spend more time studying, then my mark will increase. All right, that's my educated guess based on previous knowledge. And to test my hypothesis, I collected data. So I asked 10 students to tell me how many hours they spent studying, and then I compared that to the mark that they received. The second part, right, for the requirement would be collecting the data. You want minimum of 10 data points, and you want to display it in a neat and organized table, and that is worth 10 marks. The first part is worth 10 marks as well. It's 50 marks total. All right, so I organized my information in a table. All right, so I labeled my x-axis column and my y-axis column, and I listed my information. All right, so these are my hours studied. So the first student, okay, each line represents one student. The first student told me they studied for 4 hours, and the mark they received was 95%. So that's your data. For the third part, you're going to create a scatter plot from this data. Then you're going to add a line or a curve of best fit. Find the equation of this line in y equals mx plus b form. So you guys are going to do a line of best fit for the data that you have. So what I did is I took this data and I went into Desmos. You can graph this by hand if you like on a piece of graph paper and then take a photo and submit that. But I think it's easier if you just go into Desmos and enter the data. All right, so if you click I already have this done already, but the way I did that is I pressed plus on the left-hand side and then created a table. And this is just from, minimize this is just from Desmos.com. Create a table, and then I was able to enter my data there, and it created a scatter plot. Make sure that your graph is nicely visible. So I don't care about negative values because there's no negative hours on the x-axis and there's no negative marks on the y-axis, right? So I want this quadrant over here to be nicely visible. If you find that you have a lot of empty space down here, I have quite a bit of empty space. You could put a line break in, right? And then instead of starting at 0, well, you could start at 0, put a line break in, and then your next point could be, you know, maybe 40 and so on. So you can eliminate this empty space here like we did in class. So I did that, and then I took a screenshot of this and put it into slides. All right, put it into slides, and because in slides you can easily add a line, right, using the line feature to put your line of best fit. All right, and then you can move that around, you know, put it wherever you like it to be. You can change the color of your line if you want it to be a different color. You can change the thickness if you want it to be a little bit heavier, so on. You can add text along here, right, using the text feature. So you can add your y-axis label, your x-axis label, and a title. and then you screenshot this and put it into your document that you're going to be handing in. All right, so there's my graph that I had set up. All right. Make sure that you've got a title, your axes are labeled, you have your units, okay, in brackets. Don't just say time spent studying. Make sure that we know what units you're talking about. My data is in hours. And then mark received, my marks are in percentages, so you need to have those units on there. All right, so there it is, completed. I don't have a title here. You need to add a title as well. For the next part is finding the line of the equation of that line that your line of best fit that you put in there. Okay, that's this part down here. So I'm going to take you through and just remind you of how to find the equation of that line. So to find the equation of a line, I'll just add the equation here. Y equals mx plus b. There are two parts. The first part, you need to know what the slope is, right? How steep is that line? And then the second part is the b, which is the y-intercept. You want to know where your line crosses the y-axis. So I'm going to start with finding the slope. For that, you need two points, and they need to be the points that are on that line. All right, they're not going to be the data points, okay, that we have collected, because they're not on the line. All right, this little green one down here looks like it might be on the line, but it is a little bit lower. So you need to look at your graph really carefully and find 2 points that are really clear that you can use to find the slope of that line. All right, so I went ahead and did that. I found those 2 points. Looking at my axes down here, it looks like each little square is 0.2, right? 0.2, 0.4, 0.6, 0.8, and then 1. Okay, just looking at what my scale is. And then going up on the y-axis, it looks like each little square is 5, 10, 15, 20. All right, so I was able to figure out that this point here would be 1.2, and then on the y-axis it would be 65. And then I got a second point in the same manner, 2.275. So I'm going to find the slope between these 2 points. Remember, the slope is delta y over delta x, right? It's the differences in the y's divided by the differences in the x's. Okay, differences in the y's, y2 minus y1, right? You could alternately just draw a triangle between these 2 points and then just count, what is the height, right? What is the rise and what is the run? That will work the same way, but I'm showing you how to use the equation. All right, so I wrote down my 2 points and then I labeled them. So the first point is I chose this to be my first point. This is my second point, and each point has an x and a y. So my 1.2 is my x1 and my 65 is my y1. And then 2.2, this is my x2, and 75 is my y2, right? 0.1, 0.2. And then just sub them into the equation. Y2 minus y1, 75 minus 65 at the top. And then at the bottom, x2 minus x1, 2.2 minus 1.2. Okay, when I work that out, that gives me 10 over 1. So the slope of this line would be 10 over 1. And we would get the same answer if we drew our little triangle. All right, you could see that you're going from 65 to 75, so you're going up 10. And then across, you're going from 1.2 to 2.2, which is 1. Okay, for the second part, you want to find the y-intercept. The b part, if you look at your line, you can kind of estimate where the y-intercept would be, right? It looks like it would be at 45, 50, 55, a little bit under 55. We don't really know. Is it 53? Is it 54? We are guessing. I'm going to show you algebraically how to find that exact value. All right, so you want to start with your equation of a line, y equals mx plus b, and then you want to replace the x and y with a point on your line and replace the m with the slope that we just found. And then that will leave b as the unknown, and that's what we're going to solve for. Okay, so slope we just found, that's going to be 10. And x and y, is any point on that line that we have, and we have two to choose from that we have labeled. So I'm going to choose the first point to find my slope. You could use a second point and you would get the same answer. Okay, so I'm replacing my y with 65, the x with 1.2, and then the m with 10. Okay, multiply 10 times 1.2 to give you 12. Okay, and remember, we're trying to isolate for b. We want the b by itself, so we need to get rid of this 12. And the way we do that is it's positive, so I'm going to subtract 12 from both sides to be fair. Okay, if you subtract 12 from here, that will cross, they were going to cross out, you'll have 0. And then 65 minus 12 is 53. So there's your y-intercept, 53. Right? And you can see that we said it was going to be a number less than 55. So that works. Okay, so our equation of the line is y equals 10x plus 53. Okay, what do the 10 and 53 mean in the equation? Okay, so I just said the 10 based on our data. For every 1 hour of studying, your mark should go up by 10%. Remember, our slope was 10 over 1, right? 10 is the difference in the y. So on the y-axis, we have our percentages, and then the over 1 part, that would be the difference in the x's, and that was the hours that we're studying. Okay, so your mark should go up 10% for every extra hour that you study. And then 53 was the initial value on our graph at time 0. Okay, so based on our data, if you do not study at all, your test mark should be 53%. And the last part says, describe the trends and relationships observed in data and make inferences from data using interpolation or extrapolation. Is the outcome consistent with your hypothesis? Identify and explain any outlying pieces of data. How might you vary the experiment to examine other relationships? So you're doing a bit of an analysis at the end, and that's worth 15%. Okay, so for the first part, you want to show me that you understand what interpolation and extrapolation are. So you want to write down some points that you can extrapolate or interpolate that makes sense to the data that you collected from your line of best fit. Does your data have any outliers? Maybe it does, maybe it doesn't. Okay, what if it did, if yours doesn't, right? How could they be explained? I want you to show me that you understand what outliers are. And then for the last part, what could you do different to the experiment, to examine other relationships? All right, good luck. Let me know if you've got any questions.